Welcome to qnawire.
All right, let's go ahead and solve this problem. So we're given a problem where we want to evaluate a surface integral, and it's basically evaluating this x squared plus y squared plus z squared over the surface S, and S is given by, oh, I forgot to write down the equation. Um, the surface is given by z equals to x e to the y, where x is bounded between 0 and 1, y is also bounded between 0 and 1. So I tried to draw it in 3D. That's what it would look like, x, y, z. The projection on the xy plane would be a rectangle, which sort of makes this problem solvable, okay? All right, so what's important to remember about this problem is that the surface integral can be evaluated by basically writing everything out in terms of x and y's, and then multiplying the magnitude of the normal vector. And because of the form of how x and y can take, um, I'm sorry, the form of what z takes in terms of x and y, when you figure out the magnitude of the normal vector, you will end up getting a value that looks like this. Okay, so we're going to use this equation straightforwardly, and fortunately, we're allowed to use a calculator for this problem. We're just going to figure out what the expression would look like, and then use a calculator such as TI-89 or TI-Nspire in order to solve this problem. Okay, all right, so let's start by figuring out what each of these expressions are going to be. Okay, so we are just going to let x equals to x, y equals to y, and z is equal to x e to the y. So we know that the expression that we see right here can be rewritten as x squared plus y squared plus x squared e to the y, so it'll be e to the 2y. Okay, now we're going to figure out this one. Currently we have g of x comma y equals to x squared e to the 2y. Oh, sorry, that's actually z squared. Let me go back a step. G of x is simply the z, so g of x is equal to x e to the y. So g sub x, the derivative with respect to x, or the partial derivative of z with respect to x, is equal to simply e to the y. Similarly, g sub y is equal to the derivative of e to the y is e to the y, so it'll be x e to the y. So from here we can deduce that g sub x squared is e to the 2y. G sub y squared is x squared e to the 2y. So the expression right here, I'm going to write it as triangle. Triangle is equal to the square root of 1 plus. I can factor out an e to the 2y from both of these expressions, and you will get 1 plus x squared. Okay, now let me move this over here just a little bit. Now the final expression that we have to evaluate will simply look like this. We have a double integral, and then we're going to put in these expressions. So let's see, let me call that square, square times triangle dy dx. And I'm just writing it like that because it's something that you would have to put in your calculator. And the limit of integration is from 0 to 1, 0 to 1. And all we need to do is to plug this in a calculator. So you will end up having approximately 4.5822. 221 actually, and because the question wants us to have it accurate up to 4 decimal places, this is going to be the answer. Okay, and that is how you solve this problem.